Hey everyone, let's start with question number 13, Digital Electronics, asked in GATE examination 2025, Computer Science and Engineering branch, set 1. The question says, let x be a three variable Boolean function that produces output as 1 when at least two or the inputs variables are 1. Which of the following statement is or are correct where A, B, C, D are the Boolean variables? Before discussing this question, I want to tell you that these types of questions are given to utilize your time in exams. There are several ways to solve this question, but in this question, I will give you a key insight how you can look a midterms. Now, let's go to first break this question in two parts. Part 1 is analyzing the expression by the given statement, and the second part we will discuss with the given options and find which one is correct. Now let's start with the statement. The statement says x be a three variable Boolean function that produces output 1 when at least two of the input variable are 1. Those who know this statement can directly write the expression. I will derive this expression and let you know where this expression came several times. So first write the function. Let's say input variables are alpha, or we can say for simplicity capital A, capital B, capital C, and your output F. 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So it says that output is logic high when two or more of the inputs are logic high. So it becomes 1 here. It becomes 1 here, 1 here, and 1 here, and others are we assume to be 0, logic 0. It is minterm number 3, 5, 6, and 7. If we analyze the expression drawing the K-map for this, A, B, C, 0, 1, 2, 3, 4, 5, 6, 7. That is B complement, C complement, B complement C, B, C, B, C complement, A complement, A. This comes out to be 1 here, 1 here, and 1 here, and 1 here. So the maximum pairs are this, this, and this. Find the expression. This comes out to be AB plus BC plus CA. This is nothing but expression of a full adder carry out. Carry out is same written as AB plus BC in plus C in A. So this is an expression of carry out in full adder. If you have remembered, or no problem if you can derive as quickly as possible. So we got the expression for the fundamental expression for what the statement says. Now I will give you the concept one key concept, or you can say this comes by analyzing, or once you start analyzing the concept or looking the minterms in a different manner. If you see the elemental size of minterm in above minimized expression, because the K-map gives you the minimized expression is 2. You can see there is no minterm which is having less than 2 width, or we can say size. This is also having 2, this is also having 2, this is all. I will denote this name as a size. Size here is 2. So any elemental minterm is having the size 2. There is no minterm which is having less than 2. And the minimized Boolean expression says that number of minterms is 3. Number of minterms is 3. This you find by the using K-map. K-map can give you only the minimum number of minterms or minimum number of max terms. This does not tells you about the size of the minterms, which I told you now. The size of the minterms are only 2, 2, 2. For an example, there are so many expressions which consist of, let's say this is an example, AB plus C, where now here the size of the minterm is 1, which is elemental size. I am picking this as because this is having only 1 bit, that's why I am denoting it as a size. Here you have some more expressions like AB plus BCD. So here the elemental size can be written as 2. Why I am telling you this is because there is one possibility for reduction of the size of expression if you have a smaller size minterm. I will explain you these statements. So see, if for an example, I will let you explain with an example that will much more clear. Let's say your f is AB plus C. So there is a minterm which is of size 1, which is smaller than this size. This size is 2, this size is 1. But it cannot reduce it further. So your expression is only this. But what if your expression is having this? So there is a one possibility that this minterm can reduce your entire size of the expression, and it becomes B. Now the size becomes, the entire size of the minterm become 1. What you see that this is now no remains 2. There is only one minterm which is having of size 1. What if there is a function, for example, let's say AB plus CD. So there is no minterm which is of size less than the given minterm, that is 2. There is no minterm which is less than 2. Both the minterms are of size 2. So there is no possibility that there should be a minterm of size less than 2. So there is only one possibility of reduction of the size of the expression if you have a smaller size minterm. So there is one smaller size minterm, so there is a possibility. I said possibility, so it is not necessarily that it will reduce the size, but there is a possibility. There is also a possibility, and it reduces the size of this minterm. See, this minterm reduces the size of this minterm. So, but in this there is no minterm which is of size less than 2, so there is no possibility that the minterm size of these two can be reduced further. Now we will apply this concept to the above question in order to do this question as quickly as possible. So you don't have to memorize it or remember it. This is one of, I told you, this is one of the possible way which you can apply to these types of question, and you will recognize by your own in further questions, or by it comes by practice. So now let's see part 2 of this question. Let's pick the option A. Option A says x of a comma b, x of c comma d comma e. So what this tells you that, let's say I am taking this as alpha complete. It gives you ab plus b alpha plus alpha a. So alpha by itself gives you cd, de and ec. So you don't have to completely put the values and expand the expression. I don't want you to go to this process just because I have told you something. So let's say, and this is your left hand side. Now writing the right hand side is x of x a b c d e. Now this can be written as, let's assume this as beta d beta e plus de. Now you have to look carefully. This and this part is never going to be further reduced. It can be further expanded to size of 3 minterms, plus 3 plus 3, and this is the only fundamental minterm which is having size 2. And the same here, this is going to be expanded as size of 3 minterms, which is having size 3. Minterms, it can be more or less. I don't want to tell you that there are 4 number of minterms, 6 number. It can be, but the size can't be less than 2. It can be 3 or it can be 2. Now if you see that here is also one minterm which is having properly size 2. Now if you see that if you want to vanish or reduce AB from LHS, so you need a minterm of size less than 2. Similarly, if you want to reduce the size of DE, you want to have one minterm of size less than 2. So there is no minterm on both the sides which is having less than 2. So we can clearly say that AB is never going to be vanished and DE never going to be vanished. So left hand side is having one term AB and right hand side is having one term DE. In both the expression, LHS is not going to be equal to the RHS, because LHS is never going to create a term which is having DE, and RHS is never going to create a term which is AB. So here is never going to have AB and here never going to have DE, because the complete expression you will obtain from here will have the size of three minterms and here you will have the size of, similarly, the size of 3. So never going to have a size of 2, and you never going to have AB here, or similarly you are never going to have DE here. So you can eliminate this option by looking that AB is never going to be equal to that of right hand side DE. So your option A is incorrect. Let's go to analyze the option B. It will make you more clear. Option B says x of AB, ABC, x of AB, x of ABC, and right hand side is x of ABC. Now if we see that ABC is AB plus BC plus CA, now right hand side is AB plus B, and let's assume this to be an alpha. So you will have AB B alpha plus alpha A. So there is also having AB AB, so this is a common part. So will we further realize that what this is, this possible to be a size of 2-bit, size can be 2, because here our fundamental size is 2. So can it will be of size 2? Then we have to expand this by putting the values of alpha, because first we see that AB is common, and so hence we go further for analysis of this, because I told you it can be of size 3 and it can be of size 2. So it is possible that it can be of size 2, but it cannot be of size 1. So let's analyze that. Will it be with the remaining part? So while writing the alpha value as AB, BC, CA, and again AB, BC, CA, A, multiplying the B, it comes out to be AB, BC, ABC, similarly AB, ABC, CA. Now the complete AB, one get cancelled out, ABC also one get cancelled out. This comes out to be AB, BC plus CA and ABC. If you take one common, AC comes out to be AB, BC and again CA. That you can also see here what the statement I have given. There are two sizes of 4 minterms, two size of 3 minterms, and once there is 3 size of 1 minterm. This minterm is having size 3 and the other minterms is having size 2. So it is possible that the entire size can be changed. This minterm size can be changed with the help of these two size minterms. So yes, it is possible, and the expression becomes AB plus BC plus CA. So one of the option B is correct. Now analyze, let's say analyze, because question say is yeah or are correct. So it can be a multiple choice. Let's go with option C. Option C says X AB ACD, X AB ACD. I know this video is becoming a little longer, but it is the part of the analysis. And the right hand side is ABA CDC, X of ABA and with CDC. I think so it is written as yes. Now if you analyze this by putting the value as AB plus BC plus CA, in C becomes A, so you will get your A from this will reduce come entirely to A, and similarly this will reduce entirely to C. You will only put these values to AB plus BC plus CA. Here A becomes C, so if you put that CBC, BC, CA, this becomes BC, CA, C common. I think so I have done a mistake. Yes. Yes. This becomes A becomes C, BC, BC, and yes, here A becomes C. So it will reduce to C. So if you take common C, then it becomes B plus 1. It will become C. Similarly, here it becomes A. So on the right hand side, it is AC. There is an AND operation. So there is only a minterm of size 2, where in the left hand side there is a minterm AB. Let's assume to be an alpha, AB B alpha plus alpha A. So this expression is going to give you minterms of size 3 or size 2, but here a minterm can't be reduced, which is AB. So left hand side is having a minterm AB and right hand side is having a minterm AC. It can't be having a minterm AB anyhow. So your option C is also wrong because AB, it can't have AB here. It is possible to have AC here from this, deriving this, but it can't have AB here. So LHS is not equal to the RHS. I will remain this. So your option C is not correct. Let's go to the option D quickly. X of ABC is written as option D. X of ABC is X of A, ABC, ACC. ABC and X of A, C, C. Now you will see, if you do some smaller manipulation, it becomes A. This as it is A, B, C, and if you see, I already told you this A, C, C becomes, if you rationalize it, it becomes C. So it becomes as similar as option B. If you can see, AB X of ABC, order doesn't matter. AB X of AC, here are A and C, and here is only, the difference is only A and B. So nothing will change. If you do this analysis, it becomes AC plus, let's say assume to be at alpha, A alpha plus alpha C. If you expand the alpha, becomes AC, A, AB plus BC plus CA, and AB plus BC plus CA into C becomes AC plus ABC, and I know that you are getting the answer that comes out to be ABC, but for the surety I will write the entire expression. So ABC 1 get cancelled out, AC 1 gets cancelled out, and we got AB, BC, CA with ABC, which is further get reduced to AB, BC, CA, which is equal to the LHS. So your option D is also correct. So in this question you have two options correct, option B and option D. I hope you find this question little interesting, because it include a very small but concept which will reduce your process of doing this question. So I think this would be very helpful, and You need not to do all of this once you got a good clarity on this concept. Thank you.